to be going over the scientific notation breakout, which will help prepare you for your assessment next week. Challenge number 1. It says click here to see challenge 1, and then click here when you solve challenge 1. So let's click here, make a copy. All right, it says, while it's working here, decide whether or not each number is correctly written in scientific notation by typing yes or no in the answer column. As you answer questions correctly, a picture will reveal itself. You need the information from the picture to solve the challenge. So just looking at our answers, if you remember, when we're looking at our answers that are given, we'll look at our coefficient and our exponent. Our coefficient has to have a number in front of the decimal between 1 and 10. In this case, it doesn't. It's too small. The other thing that we need to look at is our exponent. Our exponent could be a positive or negative number, but it has to be a whole number. It can't be a fraction. All right, let's look at number 2. 10.2. We look at the front number. 10 is too big. We need it. It should be a single-digit number between 1 and 10. But it should be 9. Should be the biggest number there. So this would be no. Number 3, look at the front number. It's 1. So yes, that one works. 9.9. Then we look at our exponent times 10 to the 6. Yep, that one's in correct form. 1.0002 times 10 to the negative 9th. Yes, that one is in correct form. 11.23, we look at that front number. 11 is too big, so we nope. Number 7, 8.4505 times 10 to the 11th. Look at that front coefficient. It's between 1 and 10, so yes. Number 8, 30.34 times 10 to the negative 1st. 30 is too big, so we say no. Number 9, 6 times 10 to the 4th. 6 is between 1 and 10, so yes, that one works for a coefficient, and our exponent is a whole number. And 10 times 10 to the negative 7th. We look at the front number, 10. Think of this as 10.0. 10 is too big, so it's right, no. All right, so we're going to use the number 384 for our answer. So 384. So go back. Also, things to think about to use in this would be the poster that was provided to you by your teacher. And remember, we're going to be using 384 for our answer. So click here, 384. And we're going to click submit. And our keyword is elephant. Keyword's elephant. So if you want to just write that word down, or just remember the word elephant, and we'll move on. So we can close this one out. So what I'm referring to, that poster. So I want to show you different things from, if you're in Miss Cumber's class, that poster, the poster is actually called the Operations in Scientific Notation poster. And so it's under materials. Under Unit 7, Part 2 materials. And we're looking at this Operations in Scientific Notation poster. So you can utilize this. And this is going to help you when you're adding, subtracting, multiplying, and dividing. So I'm going to open this one up a little bit further. If you are in Miss Bonet's class, let me open up another Schoology page. Doesn't matter what class period, as long as you're in Miss Bonet's class, you are going to go to the Digital Learning folder. And let's see if we can find her poster. And operations and scientific notation poster. There it is. So you can utilize that poster to help you. It's the same exact one that I have pulled up right here. All right. The other one that might help you, come to think of it now, so let's go to Miss Bonet's, and it was for helping you prep for the assessment, the first assessment of Unit 7. So if we go to review and this exponent rules poster. So if you want to open that one up as well. And this one, it just teaches you what we were tested on earlier. All right, so we'll keep both of those available to us, and let's carry on. So we have elephants. We did challenge 1. I'm going to close that. Let's move on to challenge 2. I'm going to click here. It says make a copy of this slideshow if you want to edit it. So let's file, make a copy. I want to close this one down. All right, once this comes up. So on the next slide, you'll see a maze made up of numbers in standard notation and scientific notation. Begin in the start box and work your way to the finish box by converting the numbers from standard notation to scientific notation. Keep track of your movements through the maze. You will need them to answer to challenge 2. So let's take a look. So we're going to start here. And depending on which one is the correct answer, it'll determine which way we go. So we want to get from here all the way to there eventually. All right, so if we remember what we need to keep track of your movements through the maze. You'll need them to answer. So that's why you want to make a copy of this, so we can we'll make marks on here so we know which way we went. All right, so we have 0.00000036. We need to put this in scientific notation. This is in standard notation. So this is a tiny number, and how we know it's a tiny number is because there's a 0 in front of our decimal. So we know that's going to be a negative exponent. So we should see that we have -7 and -8. Yes, these are both small numbers, and we got to see which one's right. And then we have our coefficients of 3.6 and 3.6. So we should know when we're making this in scientific notation, we need to move our decimal all the way until we get to a non-zero number. In this case, it's between the 3 and the 6. So when we do that, that's why we write 3.6. That's why your coefficients are both of these. Now what we need to do is count how many place values we moved from our starting point of our decimal to 3.6. So we're going to go 1, 2, 3, 4, 5, 6, 7 places. And being that it's a small number, we have a negative exponent. So we are going to head down. So I'm going to, let's see, I'm going to fill that in. Let's make it blue. All right, so that tells us we went down. Now we have to look at what answer this is going to be. So we have 367 million. We need to put that in scientific notation. So right now when you don't see a decimal, these are commas, by the way. When we don't see a decimal, it's at the very end. So what we need to do for writing numbers in scientific notation, we need to have a coefficient of between 1 and 10. So our decimal would have to fall between this 3 and 6. So we need to count how many place values that would be. So we're going to go 3, 6, 7, 8. 8 place values. This is a big number. So it's going to be a positive exponent. So looking at our choices here, we have a negative exponent, so we know that's not it. Positive and positive. So we said our decimal is going to be between the 3 and 6. We are going to keep the 7 with it, so it's going to be 3.67 times 10, and we said we moved it 8 places, times 10 to the 8th. So our next move is going down, and I'm going to fill that in blue again. So we have 30. And our choice would be 3 to the times 10 to the first or 3 times 10 to the second. So right now our decimal, when we don't see it, it's at the very end. We need to move it one place to the left. So that means, and it's a bigger number, so it's going to be 3 times 10 to the first power. So we're going to go to the right. Next one. We have a small number. The reason why we know it's a small number is because of the 0 in front. We're going to look to see where our decimal has to fall. It has to fall between the 3 and the 7. And we're going to count 1, 2, 3, 4, 5 place values. And it's going to be a negative exponent because it's a small number. So it's going to be 3.7 times 10 to the negative 5th. And that's what this shows right here. So now we're going to go up. All right. Now we have lots of different options all the way around. So this one we have 0.0000367. So we need to find where our decimal is going to fall. It's a tiny number, so it's going to be a negative exponent. So we know that this one's not going to work, this one's not going to work. This one can, and this one can't. So really it's down to these two. So our decimal, we got to find where we're going to move our decimal place. We're going to move it between the 3 and 6 because we want a coefficient in front of the decimal to be between 1 and 10. If we put it after the 6, it'd be 36. 36 is too big. So it has to be between the 3 and 6. So when we do that, so our answer is going to be 3.67 times 10 to the negative, and we count how many place values. 1, 2, 3, 4, 5, 6 place values. So it's 3.67 times 10 to the negative 6. It's this answer right here. So now we're going to keep going up. Let's fill it in. So we have 3,670. So far we went down, across, and up. So 3,670. Right now we don't see a decimal, so we assume it's at the end. This is a comma. We need to move our decimal. We know this is going to be a positive exponent because it's a bigger number. So we have it down to these two because it's a positive 3 and positive 4. So now we have to move our decimal between the 3 and the 6. So it's going to be 3.67 times 10 to the 1, 2, 3, the third. So 3.67 times 10 to the third. It's this answer right here. So we're going to move across. Looking at this very tiny number. And looking at our choices, we know that there's only zeros and 3. All zeros and a 3 in here. So when we're looking at our choices, we know we're not going to go backwards. So we have it down to these two. It's a tiny number, so it's going to be negative exponents. So both of these are still in the running for a possible answer. And we need to move our decimal to be behind the 3, so we have a coefficient bigger than 1. So we need to go 1, and then we have to count our decimals. So it's going to be 3 or 3.0, either one is fine. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 3.0 times 10 to the negative 8. Or you can just say 3 times 10 to the negative 8. Both would be just fine. So we're going to cut across to the right. $3,070,000. Make that in scientific notation. It's a big number, so it's going to be a positive exponent. So we know that 6 is positive, so is this positive? So let's see what's the difference. We have 3.7 and 3.07. So we'll look at our our decimal would fall at the very end, being that we don't see it. These are commas. So we need to look, where's our decimal going to fall? It's going to fall between this 3 and the 0, so it's going to be 3.07. So then we look at how many place values we had to move it. So if our decimal is between the 3 and the 0. So it's 6 place values. So it's going to be 3.07 times 10 to the 6. Now we're heading back to our third row here, the third column. Color that in. And now we have this tiny number, so it's going to be a negative exponent. So our choice would be -5, so it's going to come down to either 3.7 or 3.07. We're looking where our decimal should fall. We want to make sure you wanted our coefficient to be between 1 and 10. So we have to put our decimal between the 3 and the 0. It's going to be 3.07. And let's count how many decimal places we would have to move. We have to move it 1, 2, 3, 4, 5 places. So our answer is going to be 3.07 times 10 to the -5th. So we're going to cut across to the right. And oops. Our next one, we have a small number, so it's going to be a negative exponent. So which our choices are both negative. We have a 3.7 and 3.7. So the only difference is -2 or -3. So our decimal is going to fall. We have to move our decimal to be between the 3 and the 7 because we want our coefficient in front of our decimal to be between 1 and 10. If we moved it behind the 7, it would be 37. 37 is too big. So 3.7, so we have to move it 1, 2, 3 places. So, and it's a small number, so -3. 3.7 times 10 to the -3rd, and gets us to the finish line. All right. So what we have to do next, let's go to the next slide. The movement code. You will enter these letters into the directional lock for this challenge. Left, right, up, down, and diagonal. So we went down, so D, down again for D. Then we went to the right for R. Then we went up. Then we went up again. And then we went to the right. And then we went, I think we went to the right again. Then we went diagonal, so that's X. And then we went to the right. And then we went down to the finish line. So our letters should be, we went down, so D, D, R, U, U, R, R, X, R, and D. All right, so we're going to enter those into the directional lock in this challenge. So let's go back to our challenge. It says click here to solve the challenge. It says enter the directions you traveled through the maze to get from start to finish. Use only capital letters. So I'm going to put my caps locks on. And we have it D, whoop, D, D, R, U, U, R, R, X, R, D. Let's submit. And our next word we're going to write down for after challenge 2 is magenta. So we have elephants for our first challenge. Answer, the keyword for after challenge 1 was elephant. Our second one is magenta. All right, let's move on to the next part. So I'm going to close this one out, close this one out. Moving on to challenge 3. So we're going to make another copy of this. All right. I'll close this one out. All right, let's take a look what we have to do in this one. It says on the next slide, you're going to need numbers written in scientific notation and a bank of numbers written in standard form. So you're going to drag the numbers in the standard form to their matching number in scientific notation. Not all numbers will be used. You're going to keep track of the letters. You will need these to solve challenge 3. So let's move on to this one. So we're just going to drag up our answers up to the correct box that matches. So we have down on the bottom, we have standard notation. Up on top are, in the colored boxes, are our scientific notation. So what we need to do is we're going to write 4.5 times 10 to the 8th. And if it helps you, put a text box here and let's write it out. So it's 4.5. So what this tells us, it tells us what our numbers are going to be in front. Well, in this case, we look at our exponent of 8. So we're moving our decimal 8 places. Being it's positive, our number is going to be big. So we're moving to our right to make this 4.5 to be a bigger number. So if I'm doing this, I'm just going to write out the number. So I have 4, and then we have to move it past the 5. So that's one place value. And then all the rest, I just have to add zeros until I have a total of 8 movements. So I went 1, 2, 3, 4, 5, 6, 7, 8. So I put the 5 and then added 7 zeros. So our number, if we put our commas in, will be 450 million. So if we're looking for 450 million, it looks like it's this one. And what we're going to do is drag it right there. So if you want to delete what you did there, please do. All right, we have our first one done. 9.9 times 10 to the negative third. So we're looking at our negative exponent. So I'm going to add a text box so I can type. And being that it's a negative number, negative exponent, that means our number has to get smaller. That means I'm going to move my decimal 3 places. So if I do that, I'm going to move it 1, and then I have to move it 2 more places for a total of 3. So 1, 2, 3. So I'm going to move it past the 9 and then add 2 zeros to it. So I'm going to put 0.009 would be our answer on that. So let's look for our answer down in the bottom. Oh, I forgot one more 9 in there. So it's going to be this one. Forgot that second 9. It's going to be this one, 0.0099. They match up. I'm going to delete this, and I'm just going to drag this up. All right. Moving over to 1.112 times 10 to the 5th. I want to look at my exponent. It's a 5, so it's positive, so that means my number has to get bigger. I'm going to go to the right. So I'm going to move it 1, 2, 3, and I have to move it 2 more places for a total of 5. So I'm going to add 2 more zeros. So I'm going to put my text box. So I have 1, and then we're moving it 1, 2, 3, so about 1, 1, 2. So then we moved it 1, 2, 3 places, and I have to add 2 more zeros because we're moving 2 more additional spots. So our answer is going to be 111,200. Let's see. 1, 2, 3. 1, 2. And it's right here. Sorry, I didn't see it right away. So I'm just going to put it there, get rid of this. Let's drag it up. All right, Next one, 3.045 times 10 to the negative 7th. The negative 7 should tell us we're moving our number. Okay, this number has to be small, so I'm going to move my decimal 7 places left. So I'm going to move it 1 and then add 6 more zeros in front, because 6 plus 1 more will get our decimal where it originally started. So I'm going to put my text box. I'm going to put 0 in front for my coefficient. And then I said I had 6 zeros. 3, 4, 5, 6. And then my 3. And then I have a 0, 4, 5. All right, so we have this number. And so we have 6 zeros. Let's see, 1, 2, 3, 4, 5, 6. Yep, it's this one right here. So I'm going to delete this. Put it there. All right, we're halfway done. 4.801 times 10 to the third. Look at that, our exponent of 3. Tells us we have to move our decimal to the right because our number has to get bigger. We're going to move it 3 places to the right. So 1, 2, 3. So it'll be 4,801. 4,801. I'm not even going to put the text box for that one. That's a pretty easy one. Put it there. 5 times 10 to the negative 6. And this negative 6 is telling us our number is going to get smaller. Our decimal is right after the 5 right here. When we don't see it, it's always at the end. This is going to tell us we have to move it 6 places left because our number has to get smaller. So we're going to move it 1, and then I have to add 5 more zeros in front of it because 5 plus the 1 that we did is 6. So I'll write that, do a text box so you can see what that would look like. So I put 0 first, 0, and I said it's going to be 5 zeros in front. 1, 2, 3, 4, 5. I'm going to add my 5 behind it for a total of 6. So let's see where that would be. Let's see if this is it. 1, 2, 3, 4, 5, 6. Nope, too much. 1, 2, 3, 4, 5, and the 6. Yep, this would be the one. We'll make sure our decimal was at the end of the 5, so I'm going to move it 1, 2, 3, 4, 5, 6. 6 place values because it's telling us negative 6. Yep, so I'm going to get rid of this. I'm going to drag this one up. 2.88 times 10 to the 4th. This positive 4 is telling us our number has to get bigger, so I'm going to move to the right. So I'm going to move it 1, 2, and then add 2 more zeros. So if I wrote that out, text box. So we had 2.88, so I want to move it 2 places to the right there, and then add 2 more zeros for a total of 4. So our decimal was between the 2 and the 8. So 1, 2, 3, 4. So our answer is 28,800. So it's going to be this one right here. So I'm going to delete this. .66 times 10 to the 9th. Our 9th is telling us our number is going to be very big. Moving our decimal place 9 places to the right. So this one's going to be a text box. Right now our decimal, do a text box again. Okay. Right now our decimal is between the 7 and the 6, so I'm going to move it 1, 2, and then I need 7 more zeros to make a total of 9 movements. So 7, 6, 6, and then 7 more zeros. 1, 2, 3, 4, 5, 6, 7. So let's make sure we moved a total of 9 places. It was between the 7 and the 6, so I moved it 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if we're finding what this number would actually be, let's put our commas in. $7,660,000. I'm sorry, 7,660,000,000 would be our answer. So let's see here. This is our match. So I'll delete this one. And we'll drag this one up. All right. So we have our letters. And it says keep track of the letters. You'll need these for number 3, for challenge 3. So what I'm going to do is I'm going to write these letters down. So we have S, then T, A, N, then we have D, A, R, D. S-T-A-N-D-A-R-D. Do you know what that word spells? It's one word. If you write it all out, you should be able to see that it's the word standard. So let's go here. Let's answer our word. It says enter the word that was revealed in challenge 3. Use all capital letters. And I'm going to type in standard. S-T-A-N-D-A-R-D. So our keyword was zipper. So our first keyword was elephant. Our second was magenta. Our third now is zipper. All right, so let's move on. Close this one out. Challenge 4. We got 2 challenges left. Over halfway. In challenge 4, it says make a copy of this document so you can type on it. So let's make a copy. Okay. Close this one out. All right. So for our directions today, it says solve each math problem below and record the answer in the boxes provided. Decimals get their own box. So pay attention to whether you are supposed to be adding, subtracting, multiplying, or dividing. The color boxes are the key to solving the challenge in number 4. So what we need to do is figure out what 3.5 times 10 to the negative second minus 3.6 times 10 to the negative third. So we're going to use our order of operations sheet here. So we're looking at our problem, and it's a subtraction problem. And we're going to follow our green here, this green box here. Subtracting scientific notation. It says first, if the numbers have different powers of 10, rewrite one of the numbers so that they have the same exact power of 10. So in this one, they had a power of 10 here, an exponent of 10 and an exponent of 9. So you need to make these to be the same. And so in this choice, they wanted to convert the exponents of both to be 9. So when they did that, they changed this one. This one already had an exponent of 9, so they didn't touch this one. This one they decided to change. So when we are moving a decimal, or when we change a decimal from 10 to 9, we are subtracting. So when we're thinking about that, we need to look at think of our acronym LARS, L-A-R-S. Since we're subtracting, it's the R and S. So that means we need to move our decimal the same number that we're subtracting by. So in this case, we subtracted by 1, because 10 minus 1 is 9. So we're moving our decimal one place to the right. So we're going to do the same thing on this one. So we have -2 and -3. So what we need to do is convert one of those exponents to either be a -2, so they're both -2, or change to -3. So what I'm going to do, I don't care which one we do, let's pick, I'm going to convert the -3 to be a -2. So -3 is smaller. So I'm going to add 1. Actually, let's do -2. Let's change this -2 to -3. So if I'm going to do that, I need to subtract 1. So just like we were talking about in the example before, using LARS, L-A-R-S. And what we're going to do, since we need to subtract 1, so -2 minus 1 would equal -3. We are going to, since we're subtracting, we're going to look at the R and the S. So we need to move our decimal one place to the right. So now we have 35 times 10 to the -2. I'll be right back. All right. So we had 35, and we're at, so what we can do is, I want to change this up here. This will probably be easier. So we moved our decimal to the right 1, so that becomes 35. And this negative 2 becomes a negative 3. All right, so now what we do, if we look at our sheet, now it says, now that we have the same exact, next subtract the coefficients and keep the same power. Okay, let's take a look. We're going to subtract 35 minus 6.6. So I highly recommend using Desmos. Desmos Scientific, if you want to do that. I want to take my caps lock off. And so you're going to go 35 minus, was it 6.6? And we get 28.4. So we have our answer 28.4. I'm going to put that there. Times 10, and we keep this all the same. So all right, times 10 to the negative third. Our last step in our document, it says finally make sure that the final answer is written correctly in scientific notation. And to know that, our number in front has to be between, our coefficient in front has to be between 1 and 10. And in this case, it was 64. 64 is too big, so they had to move their decimal. Let's take a look at ours. We have 28. 28 is too big, as we need to move our decimal one place to the left. So when we do that, it's going to be 2.84. Since we moved 1 to the left, now we went left, we're looking at Lars, we need to add 1 to our exponent. So what we need to do is negative 3 plus 1 is negative 2. So our final answer will be the decimal is a box itself, 8.4 times 10 to the negative 3 plus 1 is negative 2. All right, so what we need to do is we're going to keep track of these yellow boxes. All right, let's move on to the next one. 3 times 10 to the negative 5th times 5 times 10 to the negative 2nd. So what we're doing, let's look at our rule sheet for multiplying, because that's what we're doing. Multiplying's down here. It says first multiply your coefficients, then next multiply the powers of 10 by adding the exponents. Okay, and then we have to make sure they're in correct form. So multiplying is a lot easier. Seems like a lot less work. So we're going to multiply our numbers together first. So 3 times 5 is 15. Then we have to go 10 to the negative 5th times 10 to the negative 2nd. So what we're going to do is add our exponents. So we have negative 5 plus negative 2. So if you want to do that in your calculator, we have negative 5 plus negative 2 equals negative 7. So we're going to use negative 7. I'm going to put times, and I'm going to put this as negative 7. So 15 times negative 7. Our last step is making sure this is in scientific notation. Right now our decimal is after the 5. We need, so it's 15. 15 is too big, so we need to move it one place to the left. And when we moved it left, we put Lars. Left means add. So since we moved it only one place left, we need to add 1. So it's going to be negative 7 plus 1. You do that in your calculator.